Dr. Evanoff is an associate professor of geology at the University of Northern Colorado in Greeley. He teaches courses in sedimentary geology, paleontology, and Rocky Mountain regional geology. Emmett got his bachelor's at the University of Wyoming and his master's and PhD, University of Colorado Boulder. His research includes timing, origin, and ancient environments of sedimentary rocks 30 to 50 million years old that fell over the Rockies and Great Plains. He's worked on these rocks and their fossils throughout the Western United States, currently working on the geology of the Bridger Basin, which we're going to hear about in Southwest Wyoming, the Uinta Basin in Northeast Utah, and Badlands National Park in South Dakota. So the current project involves photos that compare older photos with today and learning about what's changed. Please join me in welcoming Dr. Emmett Evanoff. I'm going to give you the mic. Okay. I usually start this talk by, look at the two pictures up here. One of them taken in 1903, and the other one was taken on the 22nd of July, 2011, by my wife and I, Kathy Brill, who's here. This is a kind of a joint project between the two of us. And I wanted you to look at it and say, okay, what do you see different? First off. And you don't have to answer that, but just taking a look at it, look at them and see, what do you really see different?
Grass.
Green grass, yeah, well, one's black and white and the other's not. It really isn't that much difference in the vegetation in reality. When you look at it, there's actually extremely little between the two. You know, these are badlands, right? And badlands are supposed to erode very rapidly. If you look at one thing, right up here, if I can get this right there, you see that point? That's gone. And then maybe a couple other things, but in reality, there's not a lot of difference in that. But we are going to be seeing some things and look at the differences today, both in the landscapes and the vegetation. We're also going to see old fossil localities and the kinds of fossils that were found there. Remember, back in 1903, 1870, all these, they didn't have topo maps, they didn't have GPS, but what they did have was photographs. And so sometimes they would take photos, and so we can relocate fossil localities based on the photos that they took. Okay, so let's go ahead here. So here's that same diagram here. As I mentioned, the top one here, it was a panorama, as you can see, and of course we took a panorama also. And really not that much difference. There is a little bit, few more bushes, if you want to call them that, in ours, and not a lot of difference between the two. Okay, and here's what we do. Kathy and I go out, and we have the original photos, and then we go out to where we think the site is. And this helps out because I did a lot of mapping in the Bridger Basin, and I've done a lot of mapping in Badlands, which means that you walk all over it. And so then we take a look at these, and you look at a photo and say, I think I kind of know where that's going to be. And so we go out to the areas and we walk around, and it's usually an aha moment. You know, you get one, well, that's close, not quite it. And then you walk over and say, wait a minute, here it is. This is the spot. And so we find these different things, different localities. Then what we do with the locale, and we've also in the Bridger Basin down in Southwest Wyoming worked with Paul Murphy on some of this, who's done a lot of work in the Bridger also. Okay, here's some of the things we did. Here's the Bridger Basin, Grizzly Buttes East, followed by actually Bill Thompson, what is everybody called him. It was Albert William Thompson, but Bill Thompson in 1903. The Badlands, and we found that site like so. And what we do is we find the site, we of course photograph it. We also put what time of the day, what the date is, what time of day our photos in. And then also we do with GPS, we figure out the UTMs, or Universal Transverse Mercator, to the nearest meters. And then we do also latitude and longitude at the site so that if people want to come back, they can find it. Okay, and there are some differences in here. If we go back, take a look at the boulders and all, and some of the outcrops. down in the lower part, if I can get here, like in through here, where the arrow is here. And if you see, there are quite a bit of difference there, but not an awful lot. It's kind of interesting to see that. Okay, then the last thing we do, I'm going to get rid of this so you don't have to see it, is we also take a good old-fashioned Brunton compass and we do some azimuth work with these things. So we look at these things, find high points on here. Here's one at South 14 East, South 2 West, and South 22 West, which also can be used when you're out there to try to figure out where the sites are. And so we document this for all the sites that we go to and all with it. We've been doing this now for, I don't know, about over 10 years, almost a dozen years now. Okay, now, if you're not familiar with it, the Bridger Basin is not a structural basin, it's a physiographic basin. And it's the area that is basically drained by the Blacks Fork of the Green, the Blacks Fork, and then also the Henry's Fork. So it's the classic area at Southwest Wyoming is part of the greater Green River structural basin and all within there. It was named, of course, for Fort Bridger, and the formation was named by Hayden for Bridger, and also it's a Bridger formation that we looked at. Of course, what that was, Fort Bridger was at where the immigrant trails came together, all three of them, the California and Oregon Trail, and also the Mormon Road, which later became the Mormon Road, went through it. And for a while, the Mormons owned Fort Bridger. And it was in this area here. And actually in 1870 was, and also the railroad came by, but it wasn't exactly at Fort Bridger. If you look at this, you can see here's Fort Bridger down here in the yellow dot. They actually put the railroad north of there at Carter Station, which you could still visit today. And so the railroad came up over in this area and then kind of left Fort Bridger behind. But Fort Bridger was actually a military post until actually almost 1900, mainly because it was a boondoggle. The Army liked bringing out senators who they wanted to impress and bring them out for a hunting camp. So they kept Fort Bridger there for a long time. And it's actually very well preserved. If you go there, they have a wonderful exhibits there, well worth seeing. Okay, and of course, when the railroad went through, like so, it was north of Fort Bridger. So that's what it was. And the first photos we're going to look at is by this fellow, Andrew J. Russell. This is his most famous photo. It's, of course, where the Union Pacific and the Central Pacific came together at Promontory, Utah. This one here in 10th of May, 1869 is when the two came together, putting in the Transcontinental Railroad. And Russell was sort of an official, unofficial photographer for them. And his first photo, he has the first photo of Church Butte. Now, Church Butte is by Fort Bridger. It's to the northeast of Fort Bridger. And what's really interesting about this is two things. First off, notice the telegraph pole there. You see that? That's the first thing. Keep that in mind. Then the second thing, you're on the edge of the Oregon Trail. There's the ruts of the Oregon Trail. You see that coming through right there? So, of course, we go out there, and what you do is you align the various buttes. You go over here and you align this with that, and you kind of look at some of these rocks are here, and you get them all aligned. And so we come back to the next one. That's the modern day. And what I've done is taken the old photograph and put into it. There was where the edge of the Oregon Butte was. Now, some of you may remember that that's actually a dirt road that used to be US 30 and stuff. US 30 used to go through there, but now, of course, the interstate goes there, and there is no US 30 out there, but this is a county road now. But anyway, that dotted line shows the edge of where Russell's took the photo of the Oregon Trail. But of course, as you may know, the Oregon Trail was about a quarter mile wide. It wasn't a single track thing. It was a whole bunch of places across and many tracks and stuff like that going through there. Okay, so the next photos that came through was by the 1870 Hayden Survey. And this is one of his most famous photos. It's from the Red Buttes area near Casper. I don't know why that came down like that, but anyway, can I move that out of there? Okay. Okay, oh, I will leave it. Anyway, Red Buttes near Casper. Various people, this was the Hayden Survey in 1870, his first actually fairly major survey. He had a lot of people in there. He had botanists and he had artists and a whole bunch of, like two of them, S.R. Gifford, and also, let me go back. Okay, let me go back into here. Two artists and also the fellow on the right there is W.H. Jackson, who is a photographer. Now, Hayden had seen Jackson's photos in Omaha and liked them. He invited Jackson along. He said, I will not pay you, but I'll give you your expenses. You take all the photos you want. You can do with it whatever you want with them, but I get first dibs on them. And he knew that the value, because Hayden was had to go back every winter to Congress and get money for his survey. And he knew the photographs would be great for that. So W.H. Jackson came in here. His earliest photos are kind of snapshotty, but in the sense that they look like snapshots. Once in a while, he'd have a really good one on this expedition. But he also would work with the artists quite a bit, and he started learning. And later, he worked with some of the greats like Thomas Moran and also W.H. Holmes, and became an extremely good photographer with it. This one is colorized, and W.H. Jackson actually did the original coloring on this picture. So that's kind of neat. We'll get some more about that here in a minute. Here's Jackson. He was a Civil War vet. He went with the Hayden surveys. He was with Hayden all the way till 1879 when they make the USGS. And then he decided to become his own photographer, and he stayed that way. He died in 1942. So he was the last of the great survey major players to pass away in 1942. He was quite a fellow. Kind of photos he had two kinds of things. These are the size of the cameras, big box cameras. We'll talk about how he had to make photographs. One of them was a stereo camera, like the one over here on the right, with two lenses in which would take an image slightly different, just like the way your eyes work. The other one, of course, is a single one. If you wanted a plate that was, say, 10 by 6, you had to have a camera that would take that negative like that. They had no enlargement or anything like that. And in Colorado, we even carried I believe, a 16 by 24 camera. And the camera was that size in order so he could take it. And we'll get into that here in a minute. He would pack them in on mules. This one here, that he loved this mule. He called it Hypo, and that was a good name because Hypo didn't get upset about anything. And there was almost 300 pounds worth of equipment on those things with that. And he carried them all over. Okay, you will recognize where this is. You can probably even tell us where it is because you've been up there all over. But if you'll notice, there's the Grand behind the guy standing there. Now, many of you have probably seen this photo before, but if you have, what he did in order to do it, here's his, I'll talk about that in a minute. Here's the camera. He sets it up first. Then he had to go over here to this dark room. He had to make the plate. In other words, put the emulsion on it with the silver on it. He had to take that, put it into a black bag, walk it. I don't know why this is jumping forward like this. Then he had to walk it into the camera, slide it into the camera, open up the front, make an estimate of how many seconds. Usually it was about 20 or 30 seconds. Close it up. Then he had to take out the negative immediately and go back to this tent and develop it. That's how you made photographs. One day he did 16 of these. He was really happy. He got 16 in one day. Just think of what with digital cameras now. I mean, you can almost make a movie out of stuff just by the stuff. Now, this one here is interesting. It's colorized as well. And actually, if you look at the original photo, there is no camera in the background. Jackson put that in there just to show how he was doing stuff. And I doubt there's a horse sitting on a pinnacle over here on the side either. This is just a picture of his dark room that he took. Matter of fact, here's the camera. This is where he took it, and he had somebody else do the thing. And if you'll notice, there's the Grand Teton in the background. Okay, so that ties in a little bit up here. Okay, so there's Jackson's photo of Church Butte along the Oregon Trail, again, and the Immigrant Trail. Do you notice something about this? No telephone line, or no telegraph pole. Why was this? It was 1870. The railroad had gone through. So what did they do? They moved the telegraph line up to the railroad because it was easier to get to by the railroad than it was along the Oregon Trail. So if you notice, that's the one thing that you see different from Russell's photo, earlier photo. Here's our photo of the same thing. If you go back a little bit, you can see that Jackson had a big gully. There was a pretty good sized gully in here. However, when they put in the road and stuff like that, they blocked it up. So this is graded up and everything like that. There's a couple of, like for instance, this little Mexican hat rock right there. That's not there now and stuff, but a lot of stuff, some of the boulders in the foreground over here and stuff are still there. Okay, this is a very famous one that he took at the same time. This is around the 11th of September. And he took this photograph. It's at the Badlands of the Bridger, not far from Church Butte. This is a reproduction of the USGS. And if you'll notice something about this one, it's been reproduced quite a bit, but it's got, the glass plate has cracked. You've got streaks in it. You've got all this stuff going on with that. It's kind of interesting. If you look at his diagram that he made for himself of the original negative, which by the way is in Scottsbluff National Monument, Scottsbluff, Jackson, when he died, he actually donated most of his personal collection of photographs to Scottsbluff National Monument, including this one here. I was floored when I saw that. Notice no streaks, no crack. So what happened is all that damage happened when it was in archives at the USGS and stuff. And, things happen over 100 years, We have found the site, more or less. This is not exactly the same angle, but it's close. There we are in the Bridger at the same spot. And this is not an easy place to get to. We call this Jackson Ridge now. It doesn't really have an official name, but that's it. This is a picture that Kathy took, and that's myself and Paul Murphy sitting up right by where the photograph was taken. And that's the access road, not very good. It's a little crazy to come back down. You got to poke around. And yet, remember, Jackson took that with his big cameras, his tent, all of his equipment and stuff, and went up there. But then again, he was only 27 years old when he did that. But he did that with those. So we've worked in the area. This is the Geologic Map, detailed one in the area that I've worked on. And all Church Butte, you can see where that is. That's over here. If I can get the, where is it? Yeah, right in here. There's where A.J. Russell's photo was. And then these are the Jackson photosites. He had one down here, another one going up here, and he had one big panorama that he took down here. And then there was also one other in by William, by Granger. Let's go back. It's very sensitive. Come on. Anyway, Granger, these are some of the ones of historical areas that we've seen in the area. The area has got lots of the red beds or marker beds and various things like that. In the area, we've done a lot of fossil collecting in here. But what's important is the ones that are in red here were actually collected by Hayden on September 11th in 1870. All these different things such as Notharctus, we'll see what those are, Hyopsodus, Paleops, Microsis, and then some mollusks that were actually collected in the area. And the neat thing is we know that this was the area of it because of the photographs. Just to give you an idea, this is from the Joseph Leidy monograph, Hyopsodus and Microsis. Hyopsodus are in blue, Microsis, which is a little rodent. Hyopsodus is, we call them tube sheep. They're kind of a condylarth, which is a primitive ungulate mammal. Hyopsodus, Microsis, and Notharctus is really fun because it's actually a lemur that lived in North America. We also found Paleocyops in the area. The lower part is one of Leidy's diagrams of a full skull. The actual type specimens are just these two little things on the bottom, which are just a couple of teeth and stuff. But they were collected by, and these are actual pictures of the specimens that they collected back in 1870. But now we know exactly where the type locality for these, and type locality is just where the specimens that the thing was first named. Paleocyops was named off of a couple of teeth. That's all it was at the time, and that's what Hayden picked up. Okay, North Arctic, here's a good example. The one on the left over here is a complete skeleton of North Arctic, and then this one here is actually a specimen from that same area. And so it's very likely we're still getting the same stuff in the area. So it gives us an idea much better. We know what stratigraphic level it is. You know, they didn't have any idea. It was just the Bridger Formation, and that's all they knew. But we know now exactly where they are. And this is basically the lower Bridger B, we call it today. Now, in 1903, the American Museum went in and had a couple of people. It was run by Walter Granger. We also had O.P. Hay, was an important vertebrate paleontologist. And then Bill Thompson was doing the photography in 1903. And they took a whole bunch more photos. Now, their photographs were a lot better, but here's Walter Granger, and I think actually O.P. Hay out in the field. They did everything by horses. The cameras they had were a little bit more advanced and stuff like that, and a little bit more portable, but they probably still were on tripods. And Bill Thompson did the photographs. They made maps of the area, started getting stratigraphic levels down and everything. American Museum in 1903. This is a famous one that's actually on display at the American Museum of Natural History. This is a Thompson photo taken in 1903 of what we call Levitt Creek, okay? Now, we know the area out there, and we've gone back, and here it is, okay, going across here. Now, the one thing that really different, look at that juniper tree over here on the right, and it's not there anymore. And that's actually not too uncommon, because a lot of times lightning strikes will hit one tree, it'll burn the tree down, and that's it. Okay, and that's probably what happened to that one. But I'm sending where the campsite was. Now they camped here for a year or a month, and because they had horses back here along the stream, they must have had water. They had to have a water source up here. So they probably had water here. What's interesting nowadays, you go out there, and that gully is incised by about 12, 15 feet, and there's no water in it and stuff. And that's happened in the early a little bit later, 1920s and all, in which we had major incision of gullies in the western US, and a lot of water sources disappeared at that time. But where I'm standing is kind of neat, because you stand down there. Here's another view of the camp from a different angle. I really like. Do you see that little dot up there? That's a plant, right? Right on the top. There it is. Still there. 100 years later, you know, that's pretty neat. And stuff. And there's where the camp was and everything like that. As you can see, the modern stream is very, very much incised going through there. And it's neat, if you stand there, you see all these cans around. And they were there for a month, and they had 6 people, right? They were there for a month. What did you do with your cans? You threw them out, right? Well, these are the original cans. And what's neat is, here's one, pretty complete. What this was actually probably condensed milk so they could put it in. And in 1903, they had developed a thing in which the can had a big hole. They put in a plate, soldered it in, then they boiled it to pasteurize it, and then they sealed up the last little hole with it in order to seal up the whole can. And that was developed actually about 1902, 1903. So it gives us an age date of when, or, you know, idea. It's almost like biostratigraphy using cans. Okay, whoop, I'm going the wrong way. Sorry. Let's go back here. So it's kind of fun seeing how you get this. So I just think that one of the top vertebrate paleontologists in 1900s were pouring milk into their coffee by using these things back then. Okay. So here's another camp. This one's interesting because there isn't much geologically different, but take a look at the vegetation around here, okay? They're in a kind of a little juniper grove. You look in back, there's a lot of sagebrush here, not a lot of trees. Look at the top up here, we've got a few big trees and stuff like that. Okay, if you look in the modern, see how many more trees at the top? Look at all the junipers that have come in. There's been a lot of increase in junipers in the last 100 years in this region. This is one that you don't see much in the geology, but you really see things in the vegetation and all. And they camped here for about a week and stuff and then moved on. that. And there are cans at this site also. Not as many as the first one, but there's still cans there. This one here, I won't spend a huge amount of time. This is not far from the last one here, and it was one of the areas they went into. But take a look. Oops, dang this thing. Okay, there we are. Okay, take a look at the gully right here. The gully's coming through like this, and the one thing about it is modern gully is in size quite a bit now. And you also see the hills have eroded down a little bit and stuff, but there's not a lot of super difference between that and this in some ways, except for some erosion in the area. So sometimes you get a lot of change, sometimes you don't have much at all. Okay, so Headlands, this is one we've done a lot of work on. Turned out there was a fellow in 1920 who came in 1920, 21, and 22. He was a graduate student at Princeton named of Harold Wanless. And Wanless was out here and he took a bunch of photos. Here's one from 1920, and there's the same one in 2016. Again, look at this and see what the differences are. A couple of things. First off, you can see that some of the bigger pinnacles up here have now eroded down quite a bit. The ridge lines have changed a lot. Interesting, the side ridges really haven't changed a whole lot. They're pretty much the same. But the one difference is in 1920, it was eroding at the base of the Badlands. And in 2016, you can see that it's actually grading and much more vegetation and stuff here in the lower part. And that it will become very important when we're looking at talking about fossil sites. This is just north of the visitor center. You can just walk right to it easily from the visitor center at Badlands National Park. And again, here we are here. I've worked more with Justin Little also. Kathy's sitting here taking a photograph, and our friend Ed Welsh, who's an interpretive ranger, has helped us out quite a bit also. So here we are doing our stuff. Here's Wanless. He was a young graduate student, 1920 and 1922, took a bunch of photos out here, working with William Sinclair from Princeton. We got the photos from his son. This is Hal Wanless. He's actually, he has the same name as his dad almost, but everybody calls him Hal Wanless from the University of Miami in Florida in 2014. And he's been really enjoying us. And we take him out and say, okay, here's where your dad was 100 years ago and things like that. And he enjoys it. And he's been really wonderful with us. We're writing a book right now. In fact, when I get home, I got to get back on the manuscript of this, showing the journal that we're talking about, the journal that his dad made in 1920. Okay, darn, top's cut on this thing. I don't know why it's cut. But this is a famous photo, very little difference here. The one thing that is important, there's some differences in the top, not the bottom. Unfortunately, it doesn't show up all the way on the screen. The main thing to look at is take a look at this. This is a landslide over here. Okay, there's a lot of landslides below the Badlands. And notice there's very few, almost no junipers on this one here. And yet in the modern day, you get grassy flats and you get junipers. So what's happening between in 1920, when this top one was taken in 2016, well, what's happened is the landslide is still active and is moving, but not the surface. It's relatively stable near the surface. And when you do that, trees can come in. And that's what's happening here. So back in 1920, it was actually being a lot more active, moving along the top of the surface, but that landslide has slowed down in its movement and everything since then. It doesn't mean it's not sliding, but it's not moving in. It's moving in big blocks and masses at the surface, not as individual little rubble. This is probably one of the biggest differences between them. Take a look at that ridge up there going through. It's not a very good photograph in some ways, and it's a little pixelated, but we have a landslide right in this area where and then big ridge coming across here, lots of pinnacles and stuff. Well, let's look at the modern photo. You can see that a lot of that has broken down. And what has happened is the smaller landslide has now gotten really big. And if you notice, there's only maybe one or two junipers on this thing, which means this whole thing is very active today. This is a very active, and big hunks of the wall up here has collapsed down into here, and a lot of erosion on here. This is some of the largest amount. The other thing that you notice is if you look at the foreground, you get a lot of barren areas and stuff and relatively short grass. Now we have tall grass in there. And a couple of reasons that might be for that. One of them might be because of changes in climate, but probably more important, that back in 1920, all of this was farmed, raised. So they had a lot of cows, they had a lot of things. They were probably eating a lot of the plants in the foreground. And then ever since 1939, we got rid of the cattle because it became a monument in 39. And then what's happened is now we've got pretty good tall grass in this area here as well. And so the vegetation is built. And because you have so much tall grass and stuff, you're also not eroding the gullies and stuff as much as it was in 1920. So they were eroding here. They're not eroding as much now because of all the vegetation. Again, we can kind of look at this. In a way, it's kind of nice. For some reason, I couldn't get the other thing deal, but you can see, this big ridge here is missing. The pinnacles up here are pretty much gone and small, a lot more vegetation down here, more eroded areas and stuff like that with it back then. Here's another diagram. It's one of the big canyons in the area that he took a photograph of. This one's kind of interesting here. Not only do we look at there, but we do see some things. Kind of focus on, here's what it looks like today. So we go here, look at, for instance, this butte right here on the side of the wall. It's basically now just a little nubbin. One of the things also is that the streams has down cut, and I put it side to side to make it so everybody can see the two, and you can see them. The walls are remarkably not too changed. Okay, this pillar here is now probably going to fall down eventually as part of this, but you're still getting a lot of the detail stuff in here, pretty much the same. Not a lot of changes going on. A little bit of change, but not so much. This butte over here had a nice cap to it. It's now gone. And this pinnacle right over here is now totally missing over on this side. Now, these are supposedly areas that really erode, right? The erosion is mostly by the streams, some of the high points, and a little bit on high points. And this was acting like a high point is now gone. But really, it's not a lot of difference between them, which is surprising for 100 years worth of erosion in the Badlands. So it's kind of interesting with that. Okay, one thing that's also interesting, this is the old wagon road that went down to the old wagon road is now what we call Cedar Pass Road. Still goes in the same place, still goes across the landslide. They still get all kinds of problems with the thing moving on the landslide. But nonetheless, this is on the pass itself is just off to the right here. And what's interesting is it's kind of fun because that was a wagon road. And of course, they were out in Model Ts. Okay, Model T was basically a wagon that had an engine on it. It had wagon-like wheels. They were skinny. They had beautifully high clearance. They could go just about anywhere, but you had to keep working on them all the time. Every time you got gas, you had to put a couple quarts of oil into it, burned oil, things like that. And so here it is there, what it looked like in 1921, actually. And then, let's go back. Here's what it is today. And what I really like, if I go back and forth, I'm parked next to the Wallace's Model T that he called the Rachel Jane. And so I'm parked next to the Rachel Jane. But what's really interesting is there was a whole bunch of photographs of this road taken from on top of this butte. Well, when they made the road, they cut that down so they can make road fill and get the road back up to where it is today. Unfortunately, those are some of the most fossiliferous beds in the area, so they could wipe out a pretty good outcrop. They probably had a lot of fossils in it, but when they built the modern road and stuff, they changed that around. But it's kind of fun to see, again, there's the original, nice windy road going down the bottom and way it is today. Okay, this was one of the most rich fossil beds in the area. This was called Bear Creek Pocket, and it's way over on the west side of the North Unit in there. If you'll notice this thing, this is an eroding topography. In other words, you had the Badlands cliffs, and then they had these areas of bare rock with these nodules all over, and there were fossils all over this. Turtles, skulls, things like that, skeletons. They spent like a week just collecting stuff, and they only got the best stuff. They didn't pick up all the junk that's also there. What's interesting is this same area was collected in 1853 by Meek and Hayden. We know from their journals that they were in this area, and Meek's diagrams show skulls and turtles all over. They're basically tortoises all over the place. And Wanless took this photograph. Here's our photograph. And if you'll notice, it's quite different now. But back then, let's go back then. You see the nodules, you see the erosional surfaces. Since 1920, the Badlands in front of the Badlands have aggraded. Actually, sediment has come off the cliffs and not being transported across, they've actually aggraded and has buried the old fossil bed, which people who like protecting fossil beds kind of like that. When you do find an outcrop in this flat area, this is all just flat sediment out here that came off the cliffs, was deposited right down here in this area that was eroding in 1920, is now aggrading. I mean, there are places there where 4-foot high wooden fence posts have been aggraded so much right at the base of the Badlands, you get about a foot sticking out, and that's it. Or actually more like 6 inches stuck out. And those fence posts were there, put in the 60s. So they're getting a lot of aggradation at the base of the Badlands. And there's a long story why that happens, and it goes back and forth in Badlands, why it does that. But right now, what's happening is a lot of these buried. However, Wanless found this skeleton right next to where that photograph was taken in 1920, one of the best skeletons. This thing's called an oreodon. It is an extinct animal. It is an archaeodactyl with multiple toes, and it is I think it's 4 and 5 toes, and the 5th one is really reduced. They're sometimes called pig sheep, even though they're totally extinct now, but they were strictly in North America. They were here by the millions at the time of the White River deposition where the Badlands were done. What's interesting is that I was helping my friends out in 2016, giving them the photos, giving them the descriptions of where to go, and they were out. They actually found that last locality. And of course, the skeleton's now at Yale Museum today, and it's been all reconstructed. And while they were out there, they found another skeleton. If you'll notice, there's a skull up here, there's bones all over. They found another skeleton not far away, and here's what it looks like prepared. And it was kind of neat because it's right in the same area. And so it's kind of the same thing. So we can locate where a lot of these old what of these specimens were pretty, and the fossiliferous areas they worked at quite well. Now, this one was really fun. This is named for Wanless. It's Archaeotherium monoliths. The whole type, in other words, the type specimen, which is this one, a beautiful skull that was taken. Yale Peabody Museum of Natural History has it now, even though it was part of Princeton University. But during the 80s, they put all the paleo collections to Yale. Big, massive pig-like animal. Archaeotheriums are pig-like, but in reality, they're probably closer related to hippos and all. But like pigs, they ate everything. So they ate, plants, animals. We've got bones that are cracked with the teeth of these things and stuff. And so like pigs, they ate pretty much everything. But he found this skull back in July of 1920. And here's what the specimen originally looked like. And it was in a big carbonate nodule and everything like that. Of course, he took a photograph of it, but he also took where this thing was found. Okay. And so he found it right in this area. And it's actually on this diagram, it's right here. That's the nodule. And that's where the skull was. And then it was by a little ridge. And there's actually a butte right here that's called Untitled Peak. That they called that. He took this photo. So the neat thing is we can go back, and this plaque's not actually where it is. It's actually right about in here. And we can go back and now take a GPS reading of where that specimen came from. And that's pretty neat. So we can even add more information. We know where it is in the stratigraphic record, even though it was collected 100 years ago. And so part of this has been really fun. Now, again, if you look at the two photos back then, which is a little hard to see because the photo is faded, but also we've had more erosion of the ridge where Levi here, who they actually found the site, and then I went out with them later to take this photo. But what happened is they've had erosion here, and then this little fan-like thing of debris with the stream going around it. If you look at it, it was not in the original and stuff. So again, we're getting aggradation and stuff at the base of the Badlands from the erosion of the slopes and all within that. Here's a great photo of William Sinclair, who is Wanlis's professor, jacketing a beautiful little, another Archaeotherium on the other side of the ridge from where they found the other one. He had these photographs with it, and the neat thing about it, take a look. This is the same place, and basically from the same. Look at the gullies, look at the stuff. See the gullies coming around, the ridges, the background. My friend Ellen Stark, who's a paleontologist there, was working on it. They were getting it with the exact same spot from the photograph. And while Ellen was sitting there working on it, oh, here's the original specimen that he had. That was at is now in the Yale Peabody Museum. This original specimen, this entelodont, and what's interesting, while Ellen was working there, she picked up the top of an entelodont tooth, a little tiny piece of it, and it fits in that skull. Now that's pretty neat. That's why we do this stuff, you know? So now we can get that a little bit back and they can glue it back onto the original specimen. And we know that that is the site where they collected that specimen. Yeah, so anyway, I believe that's, okay, here's source of the historical photographs, U.S. Geological Survey, W.H. Jackson Archives at Scotts Bluff, fantastic resource for Jackson photos, American Museum of Natural History photo archives, and then Al Wanlis's personal photos from his dad. And with that, that sums that up. So glad to take any questions or anything like that. Yeah.
On the photograph, couple back where you had a bunch of nodules just on the floor. Is it the nodules where, bingo, right, that one right there. Is it the nodules where you were finding the fossils?
Not necessarily. Sometimes,
Right, would be the
yeah,
question.
yeah, go ahead.
For our Zoom audience, the question is, the nodules that are in this photograph, are these where the fossils are found? What's the significance of the nodules?
Sometimes yes, but not always. The skeleton wasn't in a single nodule or anything like that. And actually, it's easier to prepare them if they're not in nodules because those are hard calcite nodules. So yeah, sometimes they're in the nodules, but a lot of times they're not. They're just laying out. Like that one skeleton we had was not in the nodules and all. And in this area, when you go to the modern, there are places where the outcrop does come out and there's fossils in there, and they're not usually in nodules there. They can be though. And the nodules are probably groundwater features and stuff anyway. So we had soils in the area, and then when groundwaters came through with carbonate, they selectively basically cemented in various places to make those nodules. Okay. Good question.
Is there a Zoom question, Mike, or two?
Sorry, Mike, can you hear me?
Yes.
Okay, so I've directed questions to me. This is Cynthia, and I don't have any so far, but if anybody in the audience, the Zoom audience, would like to ask a question, please chat to me, Cynthia Blankenship. Thanks.
So I have a question. Can you tell us about the lemurs and when did they arrive in North America? When did they go extinct? I didn't even know there were. I mean, now lemurs are pretty much in Madagascar.
Yes.
How?
They were, okay.
What was the distribution?
And, Bridger was the last time they were common. Okay. The Bridger is Middle Eocene, about 50 to 45 million. You had two groups. You had the Plesiodapids, which were the predecessors of those in the Paleocene. Then starting at the beginning of the Eocene, we had the Adapids. and they were the lemur-like animals. And they did live here during the early and middle Eocene, and then they went extinct probably about at the end of the Bridger, about 45. We also had tarsiers, little tiny tarsier type primates as well. They're called the omomyids. And the omomyids basically have, they appear in the early Eocene, and they went a little bit younger than that, probably to about 40 before they disappeared. So they extend a little bit higher, even though there may be one more primate that comes in from somewhere else, way up in the middle Oligocene. But for the most part, you had them. Now, what's unique about those is what's happening is they're reflecting the vegetation types that we had here. During the Green River Lakes and during the Bridger, we probably had closed canopy forests in subtropical conditions. And the lemurs and the omomyids, the lemurs and the tarsiers basically lived in those environments. As we get later into the middle Eocene, into the late Eocene, those closed canopy forests disappear. And we end up with sort of scattered clumps of trees and things like that. And the primates disappear because of that. So we don't see them beyond that. So roughly after 40 million years, we have no primates in North America until we show up. Okay, basically. Well, that's not true. There are some South American ones in Mexico and things like that. But for the most part, at least in the United States and things like that, we didn't. But they did go here. We don't know how they link. They probably are related to modern day tarsiers and lemurs. There were connections between Asia and North America. And maybe they got across there and then were able to do it and then became isolated in Madagascar eventually. And that's some of the big questions about it. We don't have much of a fossil record between the Dapids of Western United States and the Madagascar lemurs and stuff. So that's kind of an interesting question of what happened with those. But the matter of fact, you can take the skeleton that we have back here, up this one, and you take a look at this skeleton, and then you compare it with the modern Sifaka, which is a type of lemur, they're almost identical. They're not the same. The modern lemurs are not the same family as the Adapids, but boy, they're similar and stuff in many ways, including having the teeth in the front that they used for grooming, because lemurs have a very unique set of teeth in the front for grooming. These guys did also. So, and they're about the same size. They're almost exactly the same size. But yes, they were here in the Green River Formation and the Wasatch, the Willwood Formation, the Wind River Formation, the Bridger, and then the omomyids do make it a little bit higher into the Uinta Formation of Middle Eocene. So, okay, I teach bird paleo too, so that's kind of fun. I'm not a vertebrate paleo. I'm the geologist who goes out with vertebrate paleo, the bone diggers. So, but anyway, but it's fun stuff.
I have another question on it.
Come closer, yeah.
So when you take your photographs of the site, when you find the spot where the old photograph was taken, can you also determine time of year, time of day based on shadows? And do you try and match that, or is that just too much work?
Well,
Well,
actually we know exactly, we know what time of day, and we know, in other words, morning or afternoon or midday. And we also know the dates for the 1920 photos, because Wanless made a very detailed journal that we're going to publish here this year about it all. And he talks about all his photographs and stuff and do it. And we know exactly what day. And then by looking at the photos, you can tell that. We don't bother with that. We go out and just find the things and take the photograph. One year we went in to look at the Bridger, and we tried to take the photographs, and it was August and the smoke was so bad, and they made horrible photographs. And so we have to go back and do it. But Kathy and I do it. We don't bother with trying to do it. There's one place I really want to, though, that was taken in 1903 by O'Hara from the, 1901. But we got to get an afternoon shot on that because the light's just too flat on it, right, the way I have it in the morning. So, some things like that. It would be nice to do it, but I'm not up there all summer type stuff to wait and see to do that. Yeah.
Two questions. You said that Jackson's photographs are all at Scottsbluff.
Well, a whole bunch of them are.
Is that
Yeah.
in a place where you could really go in and see them? Is it worth going there to try to see the collection?
Why don't you
So,
tell that?
yeah, so the question is Jackson's photographs, are they all in Scottsbluff? Are they accessible to the general public in terms of viewing these photographs? Is that,
Yes and no. In other words, the Park Service very much likes people to come in, and they do all the things with, you have to wear gloves that they'll give you, and you can flip through them. I did borrow the one from, for instance, to scan it, the one of the Badlands that you saw there. They did for a while have a setup with photography stuff for doing that. The problem is they had them in a basement and they had a flood in there, and they did get all the stuff out before they got it. So right now, they're at Agate Fossil Beds National Monument. They're not down at,
Fossil Butte?
no, Agate Fossil Beds in western Nebraska. They moved them up there because they were safer there. I don't know if they've moved them back yet, because they had a fellow who was a very good curator types, very watching over this stuff. And now they don't have the person like that. So I think they're leaving them up at Agate Fossil Beds National Monument.
And a second question, I don't know the name of it, but there's some modern cameras that are orthometrically correct to where you can literally measure everything on it. Do you use a camera like that?
No.
Where you can?
The only thing that I might, oh yeah, go ahead.
the question is comparing the cameras that Emmett's using to cameras that are sort of structurally identical to what was being used for the historic photographs. Can you explain the differences? Is that pretty much the question?
No, it's basically, can we get ones like, can we get cameras that'll do it at the same sort of way of doing those ratios and everything?
Yeah, you can measure and distort them to literally match exactly.
Yes, you can, and the USGS did that with photos, in other words, with film. You don't have to do that today. We always take the photo and then take a bigger area there, put it into Photoshop or something similar, and then you can stretch and, I mean, I've got some photos from the South Dakota School of Mines, and obviously the same spot, but they were all elongated this way. So you just take your thing and you put the thing, and you can actually match it right over and match them exactly. So you can do that with Photoshop and stuff like that today, which of course you couldn't do back then. And of course, all our photographs are digital. They're not film. And so, yeah, you can do that. And actually, then you also record how much extension, stretch, and you can put that into the information about the photograph itself. I haven't been doing that much with monoliths. They're not exactly the same, but they are still pretty. By 1920, they were more like a modern one. And actually, you know, the old monoliths had a photo, he had it on a tripod, but I think it was kind of like similar to, you know, in the old movies where the press cameras with big flashes and stuff. I think he had a camera similar to that because he was doing glass plates with it, but he didn't have to make them and stuff. He was ordering them and then he was just putting them in there. And he also used film camera too. Film camera on some cases that made small prints. The other ones were pretty good size. And he was also playing with some of the first colored material, which was actually color emulsions on starch. So what happens is, of course, they don't last long. Some of them are still in good shape and some of them are just horrible, you know, because they just, I mean, remember, they didn't really get good color that last until they came up with Kodachrome right around World War II. Once they got Kodachrome, that's stable. It's even better in Ektachrome, for instance. I've got Ektachrome ones that have faded over time, but Kodachrome will keep it that way in the way of film. And of course, nowadays you just digitally do it and you can adjust everything you want on that thing pretty much. And so we do that, except for the time of day. We can't do time of day.
That's okay.
Yeah. Yes, Kristen.
Up at the National Museum of Wildlife Art right now, we have an exhibit from the Hayden expedition And Jackson went along and did photography, but Thomas Moran went along and did watercolors of all these different sites.
Uh-huh,
But, so it wasn't the Bridger area, but it was Yellowstone,
uh-huh,
1871.
Right.
So just kind of interesting to compare.
oh, yeah. And there's been books comparing Jackson photos of Yellowstone. Okay, she's just mentioning that what happened up at the Wildlife Museum here in Jackson. They have an exhibit with the W.H. Jackson photographs up there from Yellowstone. And he took a lot in Jackson Hole and the Tetons as well. As you saw one here tonight, you saw those. And people have gone back and found those sites and tried to see them. The one thing that's interesting, if you're up in the mountains like this, is that sometimes it's real hard to find exactly the spot. You have to use boulders and stuff in the foreground. There's so many trees because they had forest fires in the 1800s that cleared out stuff quite a bit. And you had a lot less of these hills, and you didn't have these ginormous, single species lodgepole pine forests that cover everything. They didn't have those back then. And that's true in the Black Hills in Colorado, in up here in Jackson area and all. That's a big difference that we see with those. Jackson also did tremendous amount, 1873 to 1878, 1877, they completely mapped the state of Colorado. And I've got to talk about that if you guys ever want to hear about it. And of course, Jackson was a photographer with that. And there's been people who have gone back and like John Felder has gone back and taken found the Jackson photosites and redone those as well. But when you look at those in the mountains, you don't have these big dense forests like you've had here. And you don't get the beetle kill and you don't get the other because forest fires went through now and then and cleared it all off and then they came back, So it's one of the things that has happened with that. And we know that from the photographs, the ones that you're talking about.
Now,
So-
not many, there's a couple photographs.
Oh, okay.
Then there are all these watercolors.
Yeah.
Anyway,
Yeah, in Colorado, the most
but
famous.
it's the same story.
Yeah, we had the same thing, and Moran was working in Colorado also, and when Jackson photographed the Mount of the Holy Cross, and that became really popular, every Christian in the United States, I think, bought one of those things, because here was this, uplifting looking mountain, even Queen Victoria had one. Moran went in and really, it's not exactly where you'd see it anywhere out there. It's kind of a composite of a lot of different things, but his painting of the Mountain of the Holy Cross with the sun hitting it and everything like that, well, he's doing it exactly the same way. And that's what Hayden wanted, because every year Hayden had to go back and he had his people work on the reports and he lobbied for money. And then you also had the King Survey doing the same thing. You had the Wheeler Survey doing the same thing. And you had later the Powell Survey doing the same thing. So all of them were working, trying not to overlap much. They did a lousy job in Colorado. All of them went across into Colorado somewhere. So I got a nice talk about the 4 great surveys in Colorado. And so finally they said, okay, this is ridiculous. We're going to put this into one. And they made the U.S. Geological Survey. So that's how the USGS was actually made in 1869. And that's how that one worked out. So stuff like that. It's really pretty interesting and stuff. But it's been real fun, getting out there and here's a can and probably Walter Granger was pouring milk into his coffee out of this can, Walter Granger was one of the best collectors in the 1900s of vertebrates and stuff. He even went over to Mongolia and collected in Mongolia and stuff with the Mongolian groups and stuff. He was a pretty amazing person. So, it's kind of fun to be in their footsteps, literally. So.
Emmett, I have a question from,
Yes.
so if you go back to the nodule field or
Yeah.
the plains with the nodules, and you talked about it aggrading, and I was just curious what you think the mechanism of the aggradation is,
Okay.
because it looks very uniform. Is there an aeolian
So it's
component?
being buried. All these nodules here are being buried, okay?
How?
by sediment coming over the top of them, filling in the low parts and then filling it up.
Basically wind blown.
No, I think what's happened is that back in the 1800s and early 1900s, you had enough strong rainstorms and stuff that came through and basically reamed everything out and kept it clean. And it was actually cutting into the cliff sides, in other words, into the cliff sides here, and then just pushing all the sediment right through this stuff out into the down below. Maybe because we've dried out a lot, especially in the 30s and 50s and even today, what's happening is that you get drills, but it's just allowing the sediment to, it's not putting the sediment all the way across that are being derived off the slopes up here. They're coming across here and then being captured. The other thing, a lot more vegetation now. And one of the major vegetation things that happen in Badlands are is the sweet clover. Every 3 years, you get a huge amount of sweet clover in this area. And when you get sweet clover, and they'll grow in places like this as well, they're great sediment traps. They're sediment traps because they come out there and they'll grow. I mean, you guys think of sweet clover and you usually think that stuff gets over 6 feet high. And it's just tremendous, and it's all sticky and everything, and they grow close together. They only do it for 1 year, and then they go for a few years without it, and then they come back. And we've noticed that in some places where sweet clovers come in, we've had a lot of aggradation even in the last 10 years in those areas. So probably a couple of things, maybe a climatic change, so that it doesn't get across. And secondly, vegetation is coming back into this, especially, and sweet clover is brought in from Europe anyway. It's not a native or Asia or someplace. It was brought over and it's not native. And what's happening is it's changing the dynamics of what's happening in the foreground. So what this is, if you look at we matched it from the cliffs. See, the cliffs are pretty much the same, even though the light's not exactly the same time of day. But what's happening is that's all degrading with sediment. In other words, sediment is being deposited in this area. It's being trapped in this area. Yeah. There's one place I have a grad student or a student of mine. We were doing work out here and we're walking along, and there's some new barbed wire and it's not very good and it's easy to go across. And we looked at it, and there was a big old wooden fence post that originally was 4 foot out of the ground. Only about 6 inches was heading out at the upper part because it degraded in that area right below the Badlands cliff, probably about 3.5 feet and stuff since it was built. And it was probably, looked like a post that was done in the 60s. So it's been that much aggradation in that area. We've got other examples of different things that have happened there also that I didn't show in here just because of time.
So one last question. Somebody like Mike wanted to go back and look at fossils back east, what products of the bone wars.
Yeah.
What would be one of the best universities or museums to really see spectacular collections?
3 museums. So one chance of that. Yeah.
So the question is, if you want to see what the bone wars collected, which museums or institutions would you go to see what they collected, found, cleaned, and then preserved in different institutions?
Right. Okay. There's 3 that for the bone wars, for the Martian Cope stuff. The American Museum of Natural History bought the Cope collection.
Which collection?
The Cope collection. W.E.D. Cope stuff. He kept it. He paid for it mostly out of his own pocket, so the government couldn't take it from him. And he had this huge amount, and he needed money toward the end of his life. And Henry Fairfield Osborne bought it because he was a fan of Cope's and bought the thing. So a lot of Cope stuff's at the American Museum of Natural History in New York. If you want Marsh's quarry, Marsh relied on the government, and he paid for a lot of it himself, but he didn't keep good records. And so at the end there, the government said, okay, we need your specimens. And Marsh didn't want to give them up, but he had to. So the 2 places that have it is Yale Peabody Museum, where Marsh was, but also the Smithsonian. And there's even jackets of bones and stuff from Marsh that have never been opened and stuff like that, because he had so much stuff. He never could get to it. And so that's one of the things there. If you want to look at the Wanless collection, Princeton had it and they closed their vertebrate paleontology. So the whole collection went to Yale, and Yale has now photographed all of them and they're online. So one of the things in our book, I'm going to have Wanless's list of all the fossils that he collected, which he made a nice list about. And I'm going to put where you can actually see it in the website of the Yale Peabody Museum, and you can see them. Well, the ones they didn't get rid of. There was some they got rid of. Well, we're going to finish up the manuscript by the end of June, and then it's going to take a while for it to be published.
I'm sure we know when that book becomes.
It's going to be in Springer, and the neat thing about Springer is not only are you going to do that, it was funny, about 2-3 years ago, I was out in the field with Hal, the son, and I'm saying, you know, I really want to do this book on the repeat photos, because we're going to do this as a repeat photo book, right, of the Wanless stuff. And I said, yeah, sometimes we really should do the journal as well. I mean, the journal's that thick. And he typed it up in 1921. He took all his field notes, and that's the way Wanless was. He typed everything up and he put 118 plates in it, and you know, a whole bunch. About 50 of them are good, so we're only going to have 50 of them. But he did all that, and then just kept it as a memento. And Hal, of course, got it, and then he sent me a copy of it, and I went, well, nuts, because I could tell everything where they were, and because I've mapped the Badlands, all 50 miles of them. I've been all over the thing. And to do this kind of stuff, you really need to be able to know the area. You have to map it, really know where you're going to be. So you look at the picture and say, you know, I think I know where that is. And I can't do it for all of them. There's some I still have no idea where he took the photo. But some of them, we've got about 50 photos now with it. And I said, you know, we ought to publish this journal. And so Hal finally read the journal and said, got all excited, started typing it up and everything. This a couple of years ago. And we were having a hard time finding a publisher, but we found out in April that Springer wants to do it. So we're going to try to, I had to, of course, give this talk, and there's a couple other reasons I wanted to come up here. But as soon as I get back, I'm going to be working on that manuscript. We've got most of it done, but there are some tweaking we have to do. So anyway.
Cynthia, are there any other questions on Zoom?
Nope, we're good. Thanks very much. Thank you, Emmett, on behalf of everybody.
Yeah.
We had, I think, a maximum of 21 people on Zoom, so very good attendance. And again, everything worked out very well for us remotely.
Good. Well, it's been a lot of fun.
Yeah. So Emmett, on behalf of the geologists of Jackson Hole, we have a small token of our appreciation. You can pull it out and show it in front of the camera.
Oh, okay.
I want to remind our audience that not 2 weeks, but 3 weeks, Dr. Bob Smith. Well, I know you said you're not a
Mammoth tooth cross section.
yes.
That's very nice. That's gorgeous. That's beautiful. So,
Well, thank you very much.
Sure.
It's the usual drill with the chairs, and please join me in thanking Emmett and come up and ask a question.
yeah. Hey. It's been fun.
Great job. Thank you.
Okay. You want me to get out of